Due to the growing world population in recent decades, the demand for infrastructure construction has grown rapidly. This has led to a certain degree of mismatch in the management of supply and demand for building materials. At the same time, as the concept of environmental protection has been deeply rooted in the hearts of the people in modern times, the construction industry and the public have begun to favor environmentally friendly and low-cost building materials. Therefore, researchers are trying to design and develop sustainable building material alternatives that meet the growing demand and the requirements for environmental protection and low prices to replace traditional unsustainable building materials. As the population continues to grow, new requirements are put forward for agricultural production to meet the rising demand. The expansion of agricultural production inevitably produces more agricultural waste. Typically, agricultural waste refers to various excess materials generated during the cultivation and processing of raw agricultural products such as fruits, vegetables, meat, dairy products, and crops. The material composition of agricultural waste is usually determined by the system and type of specific agricultural activities. The composition is usually complex and diverse. Therefore, although agricultural waste contains substances that are beneficial to humans, in most cases its economic value is lower than the cost of collecting, transporting, and processing it for beneficial uses. This means that in most scenarios, agricultural practitioners do not recycle or process it, but instead use methods such as incineration and on-site landfill to treat it. These traditional methods of treating agricultural waste may bring pollution risks to the environment, such as groundwater pollution, river pollution, soil pollution, air pollution, etc. However, there are studies showing that agricultural waste and its byproducts can be used to develop feasible and preliminary solutions to address the above-mentioned problems. The use of agricultural waste in building materials is not a recent phenomenon. On the contrary, humans have a long history of using agricultural waste such as straw as building materials. Nowadays, the research and application of agricultural waste in building materials has begun to take shape. The increase of agricultural waste, its widespread availability, low cost of raw materials and strong demand are promoting the advancement of research in this area.
For the key findings, we're exploring the use of the rice of ash, withdraw, or corn straw in the sustainable construction materials. In the mechanical properties, the rise of ash or corn straw fiber can improve the concrete compressive strength due to its polysolanic effect. It also enhances the tensile strength but requires chemical treatment to improve the durability and reduce water absorption. For the conductivity, using the rise of ash in the construction material can reduce the form of conductivity, as the lower probability is better to use to enhance the insulation properties. For the durability and sustainability, the rise of ash can increase the resistance to chloride ion penetration to improve the durability. Also, using the agricultural waste to reduce the carbon dioxide emissions and minimize the energy consumption. For the environmental impact, the life cycle assessment shows that the agricultural waste-based concrete can reduce the greenhouse gas emission and energy use compared to conventional materials.
I will introduce the uses of agriculture waste, particularly corn straw and wheat straw in construction materials, has garnered significant attention due to its environmental and economic benefits. Literature reviews shown how the utilization of these agriculture waste. At first, the corn straw can be made into turns lightweight terracotta bricks. The corn straw can be added to clay bricks as a pore forming agent to significantly improve the thermal insulation and water absorption of bricks. With the increase of corn straw content, the porosity and water absorption of bricks increase, but their bend strength and bulk density decrease correspondingly. This result shows that corn straw can effectively reduce the density of bricks while improving the thermal insulation performance of the material. Then, corn straw can be combined with calcium hydroxide forms, flame retardant, corn straw bricks that exhibit excellent flame retardancy. The flame retardant mechanism relies on the calcium carbonate barrier formed during high temperature treatment, which delays the pyrolysis of the corn straw fibers. This interaction significantly enhances the material's resistance to fire, making it suitable for use in buildings where fire safety is a priority. The use of corn straw helps farmers minimize burn and increasing waste accumulation and pollution, reduces energy consumption during production, and decreases the carbon footprint of construction materials. Next part is how to use wheat straw. In recent years, the application of wheat straw and 3D printed building materials have begun to attract attention. The study found that wheat straw fibers can be combined with wheat taste or other polymers to create lactate and strong 3D printed building materials, which can be used to quickly build low-cost or currently friendly building structures. The last one is rice husk, although it cannot be directly turned into a useful building material. But such as rice husks and sugarcane have also been studied for use as insulation materials, which exhibit good thermal and mechanical properties. When combined with concrete or plaster, the use of agricultural waste materials like corn straw and wheat straw in construction offers numerous environmental and economic advantages, including reduced carbon footprints, enhanced thermal insulation, and improved fire resistance. While these materials are still under research and development, their potential in creating sustainable, eco-friendly building materials is significant. Continued advancements in material processing and composite development are expected to overcome current challenges, allowing for more widespread adoption of these materials in the construction industry.
Products like rice husk ash, wheat straw, and corn stover are now sustainable alternatives to traditional construction materials, reducing our dependence on non-renewable resources and aligning with global sustainability standards. These materials are lightweight, provide excellent insulation, and lessen the environmental impact of construction. However, challenges remain. The viability in physical properties of these materials and their potential degradation requires ongoing research and improvements to ensure their reliability. Looking ahead, we need to standardize the quality of agricultural waste materials and enhance processing techniques to integrate them seamlessly with conventional materials. Developing new, environmentally friendly composites is essential for their commercial viability. In conclusion, using agricultural waste in construction is a practical, resource-efficient strategy that supports global environmental goals and could dramatically change the industry. That's all contents of our presentation. Thank you for your listening.